Picture this: the ocean surface, calm but deceptively warm, begins to stir. A simple breeze grows into a monstrous force capable of leveling entire cities. This is the birth of a hurricane, a weather phenomenon both awe-inspiring and catastrophic. But what turns a gentle tropical breeze into a deadly storm, and how do we categorize the true ferocity of these storms? Let's dive into the science and stories of some of history's most notable hurricanes. The formation, how hurricanes are born. Hurricanes are part of a broader category called tropical cyclones. These rotating systems of clouds and thunderstorms form over warm ocean waters near the equator. For a hurricane to form, specific conditions must align. Ocean temperatures must be at least 80 degrees, and there needs to be enough moisture and low wind shear for the storm to develop vertically. As warm air rises from the ocean, cooler air rushes in to fill the void, creating the characteristic spinning pattern of a hurricane. This spinning air creates an area of low pressure at the center, known as the eye of the hurricane. The eye is deceptively calm, while the eye wall, the area surrounding the eye, is where the storm's strongest winds and heaviest rains occur. Surrounding this are the outer rain bands, extending hundreds of miles from the storm's center. The power of classification, the Saffir-Simpson Scale. We classify hurricanes based on their wind speed and potential damage using the Saffir-Simpson Scale. Let's break down these categories. Category 1, winds between 74 and 95 km/h. While these storms bring minor damage, such as broken branches and power outages, they're often the precursor to something much worse. Category 2, winds between 96 1 to 10 mph. At this stage, we start seeing structural damage, trees uprooted, homes with roof damage, and extended power outages. Category 3, with winds of 107 129 mph. Category 3, hurricanes bring severe destruction. Buildings can lose their roofs, and coastal areas face extreme flooding. This is when large-scale evacuations become necessary. Category 4, winds range from 130 156 mph. These hurricanes cause catastrophic damage. Buildings are heavily damaged and infrastructure crumbles. The aftermath often leaves areas uninhabitable for weeks. Category 5, the ultimate storm, with winds exceeding 157 mph. Category 5, hurricanes are rare but devastating, leaving a trail of destruction that can take months or years to recover from. Real-life hurricanes, Milton and Helene. Hurricane Milton might not have reached the record books, but it left lasting scars on communities in its path. As a Category 2 storm, it brought heavy rain, regional flooding, and significant wind damage. It's storms like Milton that often fly under the radar, but leave lingering effects for years, destroying infrastructure, disrupting lives, and creating economic burdens for small towns and cities. In contrast, Hurricane Helene was a force to be reckoned with. Making landfall as a Category 3, it devastated coastal communities with powerful winds and massive storm surges. Though not as infamous as other hurricanes, Helene reminded us that even mid-tier storms can wreak havoc, displacing thousands of people and causing billions in damages. Beyond the wind, the hidden dangers of storm, surges, and flooding. While hurricane winds grab the headlines, the real danger often comes from storm surges and flooding. A storm surge occurs when a hurricane's powerful winds push seawater onto land, creating waves as high as 20 feet that flood coastal areas. Even a Category 1 storm can cause a deadly storm surge, and in Category 5 storms, this surge can inundate entire towns, washing away homes and businesses in a matter of hours. In addition to surges, hurricanes bring torrential rains. Hurricanes can dump 6 to 12 inches of rain in just a few hours, causing widespread flooding. For example, Hurricane Harvey, a Category 4 storm, caused unprecedented flooding in Texas in 2017, leaving thousands stranded and billions of dollars in damages. Climate change, a catalyst for more destructive hurricanes. Climate change is adding fuel to the fire, quite literally. As global temperatures rise, so do sea surface temperatures, the primary ingredient for stronger hurricanes. Warmer oceans lead to more intense storms that last longer and drop more rainfall. Studies show that while the total number of hurricanes may not be increasing, the proportion of Category 4 and 5 storms is on the rise. Coastal cities like Miami, New Orleans, and even international cities like Manila are now facing the increasing risk of catastrophic damage in the coming decades. The role of technology in hurricane forecasting. Despite their destructive power, hurricanes are no longer as unpredictable as they once were. Advances in meteorology and technology have allowed us to predict hurricanes more accurately and sooner. Satellites, ocean buoys, and radar systems give meteorologists a clearer picture of where and when a hurricane will strike. This increased accuracy has saved countless lives by providing people with enough time to evacuate or secure their homes before disaster strikes. One of the most significant tools in predicting hurricanes is the use of hurricane hunter aircraft, planes that fly directly into the storm to gather crucial data on wind speeds, pressure, and the structure of the storm. This data feeds into complex computer models that help track the storm's path. Hurricanes are a stark reminder that no matter how much we advance technologically, nature's power remains untamable. From the small, barely noticeable tropical disturbances to the monstrous Category 5 storms, hurricanes are forces we cannot ignore. And as climate change continues to alter our planet, hurricanes may become even more dangerous and unpredictable. The question now is, are we prepared for the hurricanes of the future? The technology is improving, but the question remains, will it be enough?